Hi, welcome to the topic on Introduction to Dimensionality Reduction. By the end of this topic, you will be able to describe the issue caused by the high number of dimensions in the dataset. In the last module, we learned about the linear regression model and feature engineering, which deals with creating new features. In this module, we will be looking at cases when we have too many features in our dataset. What issues can it cause? How to detect when we have unnecessary features, and explore different techniques to counter the issue of high dimensionality. Now you may ask, what is high dimensionality? Let's try to understand it with the help of a small problem. Let's say we have a problem where you want to predict the salary of employees of a company. We have a variable named age, using which you want to predict the salary of employees. Now you can train a model, let's say a linear regression model. Once the model is trained, we can predict the salaries for new observations. Now, if we were to visualize the results to find the relation between the age and the salary, we can simply do that by plotting the scatter plot between the two variables. We can clearly see in this plot that as the age is increasing, salary is also increasing. Now let's say we have one more variable, occupation. We can again follow the same steps. Using both of the independent variables, we build a model and use this model to generate predictions over the unknown data points or new observations. When we had one variable, visualization of the target and the independent variables were easier, and we visualized the relationship between that variable and the target variable using a single graph. Now, when we have two variables, visualizing the combined effect of these variables on the target variable will not be easy, as it will be a three-dimensional graph. Now imagine what would be the case when we have things like CGPA, country of residence, experience, and more. These input variables are nothing but the features or the dimensions of the data. Now as the number of independent variables increases, the dimensionality of the data increases. And in real-life business problems, we generally have a very large number of independent variables and hence leading to high-dimensional data. As the number of dimensions increases, visualizing these variables becomes tougher and tougher. Also, do you think all these dimensions or variables are important to decide the salary of the employee? Certainly not. If you look closely at this particular problem, variables like is fresher, age, occupation, and experience will highly impact the salary. So there might be situations where all the available variables are not important to predict the target, and hence we can drop such variables. Now, as we have already seen that having high dimensional data leads to many challenges, let's pin them one by one. As the dimensions increase, it becomes difficult to visualize the relationships. Also, all the variables might not be important to predict the target variable, and hence we are required to get rid of those irrelevant variables. Moreover, the computational requirements will also increase as the number of independent variables increases, and hence there will be an increase in the computation time. Next, while dealing with high dimensional data, the model will try to learn from all the variables, even the irrelevant ones, and hence we will have a complex model and interpretability will be hard. Finally, data exploration also becomes difficult when we have more dimensions. So, what can we do to reduce the number of these variables? This is where dimensionality reduction comes into the action. Dimensionality reduction is the process of reducing the number of variables from the data, ensuring that the reduced data conveys maximum information. We will now look at some of the most simple and most common dimensionality reduction techniques. For this, we will be looking into the concept called feature selection. Within feature selection, we will first be looking at the simple techniques like missing value ratio, low variance filter, high correlation, and some other advanced mature techniques such as backward feature elimination and forward feature selection. We will first understand the simplest of them, that is missing value ratio, in the next video.